Now, another form of heat transfer that's important that we talked about, it's also important to understand how that relates in the real world. When we have heat transfer by radiation, that has a big impact on our cooling loads. So it's important to recognize that a lot of our cooling loads are the result of intense solar gain. And that's why we have overhangs on buildings. It's also important to recognize that the angle of the sun is essentially lower in the winter months than it is in the summer months. And so, as we can see here from this graphic, the sun in the summer months is higher in the sky, so overhangs can help shield the house from the hot summer sun. But in the winter months, when the angle of the sun is lower, those overhangs then do not block the sun, and so we actually can get some solar gain and actually optimize the sun to help us heat our homes in the winter, but help keep cool in the summer. So when we talk about orientation, what we're really referring to is a home's orientation to the sun. How is it oriented? So for example, here we can see that the back of this house has a southern orientation. That means the back of the house faces south. If it had a northern orientation, it would be just the opposite. So when we talk about orientation, we're really looking at how the house is oriented towards the sun. Now, when we talk about windows, it's important to recognize that new windows today have a label and a rating system. So, for example, the three big things that we look at on a window are essentially its U factor, which, as we said earlier, how conductive that window is to heat. So a lower U factor is better because it means it's less conductive. So, for example, this window here will let in or out 0.35 BTUs of energy per square foot of that window per hour for every degree of temperature difference between indoors and outdoors. Another number that's important to understand is the solar heat gain coefficient. The solar heat gain coefficient of a window is simply the percentage of heat from the sun that gets through the glass. So for example, this window lets in 32% of the sun's heat. That means it blocks about 68% of the sun's heat. So that's a pretty good window. Another number that we see on here is the visible light transmission. That's the percentage of light that gets through the window. We want that number to be as high as possible, obviously. Another number that is on the NFRC label, which is a sticker that's on the window, is what we call our condensation resistance factor, and essentially that's a scale of 0 to 100, 100 being the greatest resistance to condensation. The reason why we care about that is that in colder climates, when warm, moist air of the home comes in contact with a cold surface, you get condensation. So a better performing window is more resistant to condensation. So we want that number to be high. Typically, if we have a low U factor, the lower the U factor, the greater the resistance for condensation, which is annoying and can cause even some moisture damage. Okay. Now we look at spectrally selective and low E coatings, for example. These are coatings that are designed to reflect the heat from the sun in the summer months, but also keep the heat reflected in the house in winter. So they're products that perform both in winter and summer. So when you hear people talk about low E coatings on windows or spectrally selective low E coatings, what they're really referring to are coatings that help reduce the window's heat loss and reduce the window's heat gain in the summer months. Now, another factor that we want to think about when it comes to understanding the efficiencies of our furnaces and our air conditioners. For heating systems, for example, our furnaces are rated by what we call AFUE. That's annual fuel utilization efficiency. Basically, it's how well the furnace utilizes that fuel. In other words, the higher the number, the more efficient it is. So for example, if we have a furnace that has a 90% efficiency or 90% AFUE, that means that 90% of that furnace's energy goes into heating the home. 10% of that energy goes up the flue. So typically the minimum requirement for new furnaces today are about 78% efficient. Now we rate the cooling of cooling equipment by its SEER rating, its seasonal energy efficiency ratio. Sometimes we use what we call EER, which is just its energy efficiency ratio, but essentially for any air conditioning system sold in the United States today, it has to have a minimum SEER of 13. So if I go, say, from a SEER 6 to a SEER 12, I've just cut my air conditioning costs in half. So the higher the SEER, the more efficient the air conditioner is. So in summary, we care about energy basics because it helps us create a better thermal envelope. It helps us create homes that have lower heating and cooling costs. But in general, it's important to remember that we have heat transfer by conduction, and we use insulation to reduce heat transfer by conduction. We have heat transfer by convection. That's when wind blows across our home, it pushes air in and it pushes air out. We pay to heat or cool. So when we weatherize our home, we do a lot of air sealing to prevent heat transfer by convection, or basically to reduce air infiltration, exfiltrating. That makes our home more comfortable as well. And then we have heat transfer by radiation. That's why we sometimes put shade screens and things like that. We have overhangs on homes. We have low E coatings on windows to reduce that heat transfer by radiation, which is basically heat transfer from the sun radiating onto materials, and then that absorbs that heat. So it's important to recognize as we select products and we go through our weatherization process that we understand heat transfer so we can do a better job of making our homes more energy efficient.